Hello, this is the Machine Learning Foundations for Product Managers project. So what we're doing today is we're going to build a combined cycle power plant predictor. We want to predict the electrical energy output based on the average ambient environmental readings. So what I did here, we brought in the data that has over 9,000 rows of data from these environmental readings. And then the columns represent the features and the targets, and you can see what those are here. The outcome we're looking for is we want to predict the energy output produced for any given time window. So the hope here is that we can take data that has a bunch of ambient readings and predict what our output would look like for any given time period that we would desire. Our output, we're going to focus on the regression error metrics. We're really looking to maximize our accuracy of the energy output predictions based upon these environment variables. We will use the mean absolute percentage error to choose a model that minimizes the total error. I chose this particular one just because it's, to me, very intuitive to understand the concept of accuracy. And so just to me, it made the most sense as far as being able to understand how we can compare the models together. The approach I took using the training that or the all the information that we learned in our class, the data itself is a continuous time series data over each row represents an hour worth of readings. This is historical data, and we also have the target data along with it. Therefore, we can use a supervised learning approach. And also, since we're predicting numerical target values, then we need to be using a regression approach for our machine learning modeling. So as I was looking at this and looking at some kind of how to tackle this, the model proposals that I came up with, really since we have all these features that are supplied, I'm assuming that these were valuable features and come from someone who understands that these features do determine what the output is. So we will use all the features in the modeling. Our target is, again, the net hourly electrical energy output. And our algorithms, I'm proposing that we use a few different algorithms to test. We have a known form to model, and we have a relatively small data set. So I'm going to try to use parametric algorithms here. And really want to try a couple different ones here, three actually. Start with multiple linear regression, and then also see what happens when we use another algorithm like ridge regression. And since also actually tried lasso regression, but since we are not performing feature selection right now because we know we have every feature represents an environment variable that is important to some degree, I decided to use ridge regression instead. And then also I tried another one, which is called elastic net regression. Our hyperparameters for multiple linear regression, there is no hyperparameters. And then for other two algorithms, there's a lambda that's a hyperparameter, and it controls the strength of the penalty on the coefficients. Our lost cost function, there's a few that I was going to look at. Mean squared error, sum of squared errors, mean absolute percentage error, and then also we'll potentially regularize a cost function to add more balance as well. So what I did is I took our training data. I'm going to use 80% of it for training and validation. And then as part of the training data, as part of that data, that 80%, I'll use k-folds cross-validation for the model comparison and to give us our best chance of generalizing on any new data that we will run across. And we'll take the remaining 20% of our test set and use that for testing once we figure out which model appears to be optimal. And so what I did was I wrote code in Python using SciNet, NumPy, and Panda, and put all the models in there and ran, first of all, my cross-validation results on my training data. And if you look here at the results, the linear regression results were a MAPE of 0.8009498 with an accuracy of 99.19905. I kept all the decimals because, as you can see, if we move on to the ridge cross-validated results, it's very close with a very close MAPE and accuracy. And this is the same thing I found when I ran it on ElasticNet cross-validated results. Frankly, when I saw this, I was not sure if I was doing everything right, but I did confirm that this can happen if you have a small data set, and some other pieces of it can allow the models to be close. Plus, just using linear regression by itself appears to be highly accurate for predicting results. So I took these results on my cross validation and then ran and then said, okay, well, which one is the best performer? And based upon that, determined that actually that the multiple linear regression is the best performing model of these three. I didn't expect that. I thought the other ones, because they were more sophisticated, would be more accurate, but it turns out that that was not the case. Although, as you can see, it's very close. All the results are very close and very accurate. When I ran this on my test predictions, you can see the coefficients that we got for each of our dependent variables, our independent variables and our features. Then there's the intercept as well that represents the I guess the intercept along the line itself on the model. And then the MAPE is 0.7932 and the accuracy is 99.20670. I was surprised that the predictions outperformed the training and running through the cross validation. However, I did some research and determined that can also happen due to some of the same issues of having a relatively small data set, and with the accuracy being so high, it's not. This can happen. So the final model that I'm proposing that we use for this was these are all the 4 features that we have included in the data set, plus and then the target would be our net hourly electrical energy output. The algorithm that performed the best was the multiple linear regression algorithm. Has no hyperparameters, and the loss function that I chose to use mean absolute percentage error. I did try out a bunch of other functions, and they all, and I just felt like this one was the easiest to understand because it shows you the accuracy, and then the MAPE shows you kind of how little the error is across in a way that, to me at least, is easier to understand than some of the other metrics. As I mentioned, the tools I use Google Sheets to bring the data, VS Code to do my coding, Python, and then these Python libraries. And I think that I've covered everything in this project. I have to say the project took me a lot longer than doing the training courses themselves, but also took a lot of time to learn Python and Skykit and other VS Code stuff that I haven't used or used very little. So it was a great learning experience. Thank you for your time.